Hi guys, so this is question 4 on the Unit 1 Summer 2019 WJC past paper. So this is a geometry question and we're told the line L1 passes through the point A1 minus 1, 3 and B 2, 9. The line L2 has equation 2y plus x equals 25 and intersects line 1 at the point C. Line 2 also intersects the x-axis at the point D. And firstly we're asked to show that the equation of the line L1 is y equals 2x plus 5. So the first thing we need to do here is we need to know the equation of a straight line. And that is y equals mx plus c. Okay, so we need that. So our first part, so we're using points A and points B. We're going to use minus 1, 3 and 2, 9. I like to set them next to each other and then label the top as x's, x and y's, x on the left, y on the right. We're going to label that one and that one too. And so we need to use y equals mx plus c. So the first thing we need to find out is this m, which we should know is the gradient. And then we're going to have to find this c, which is the y-intercept. Okay, so to find out m, that's another equation, so gradient, and that's the change in y over the change in x, so and that's, we can write that as y2 minus y1 over x2 minus x1. Okay, so let's use our coordinates and do that. So y2 minus y1 over x2 minus x1, which, looking at this, we're going to have, so for y2 we have 9 minus, for y1 we have 3, so 9 minus 3 all over, for x2 we have 2, so we're going to have 2, and then we're going to have minus, and then for x1 we got minus 1, so we're going to have minus 1. So here we now have 6 over 2 minus minus 1, so that's going to be 3. So we know our gradient equals 2. So, and we've just worked out m, so m equals 2. Okay, and now we need to find the y-intercept, so part C. So we don't have a graph, so we can't use a graphical method. We can, what we can do is insert points into our equation we've just made. So we've got y equals, so plug in m equals 2 into this equation, so we've got 2x plus c. So we still need to find this c. So we can just, because we know this point lies on this line, we can just use their coordinates. So we can use 9 equals 2 lots of 2 plus c, and that's 9 equals 4 plus c, and then minus and 4 from both sides, we get 5, well, we'll have 9 minus 4, which is 5, equals c, so c equals 5. So then using that, we can now put it into our equation, so we now have y equals 2x plus 5, and that should be what we were asked to find. Yeah, so we're told that L1 equals 2x plus 5, so this is, so show that the equation L1 is y equals 2x plus 5, so y equals 2x plus 5 as required. Okay, so now let's have a look at part D. So find the coordinates of the point D. We've been told in our question that point D is where L2 intersects the x-axis. Okay, so we need the line 2, which is 2y plus x equals 25. Okay, so part B. I'll bring the question down. So 2y plus x equals 25. So L2 equals 2y plus x equals 25. And we're told that point D is when L2 intersects the x-axis. So, like before when we had y equals mx plus c, this is the equation of a straight line. This is how we like to see it. We don't quite have it in the same way. It's written a bit differently. So I'm going to just quickly write it as the way we usually deal with straight lines. So I'm going to have to minus x from both sides, so I'm now going to have 2y, x will cancel, equals 25 minus x. Okay, and now I'm going to get it into 1y, so I'm going to divide both sides by 2. So I'm now going to have y equals 25 over 2 minus x over 2. I'm then just going to move the terms about to get it in mx plus c. So y equals minus x over 2 plus 25 over 2. Okay, so that's how we like to write equation of a straight line. And what we can see from this is that we have a negative gradient. So if I was to draw out our line here, I know that it's going to go downwards because it's a negative gradient, and I know it's got a y-intercept of 12.5, which is just 25 over 2. So my line looks something like this. And this point here, where it intersects the x-axis, that is point D. So when it intercepts the x-axis, so this is something we need to know. So when it intersects x-axis, that is when y equals 0. So I can now use my formula, y equals minus x over 2 plus 25 over 2, to find out what x is. So I can put y equals 0. So 0 equals minus x over 2 plus 25 over 2. And now I'm just going to go, I'm now just rearranging to solve for x. So I'll add x over 2, well, I'll times by 2 first, so this will make it a bit nicer. So I'm going to have 0 equals minus x plus 25, and then I'm going to just add x to both sides. So now I've got x equals 25. So my point D is when x equals 25 and when y equals 0. Awesome. Okay, so now we're asked to show that line L1 and L2 are perpendicular. Okay, so for part 2. So for line L1 and L2 to be perpendicular, we have an equation for this. And that's when the gradient of L1, which is we'll call M1, multiplied by the gradient of line 2, which we'll call M2, that has to equal minus 1. So let's have a look at what M1 is. So we found out our M, so our gradient here, this is L1, so that's 2. So M1 equals 2. Let's have a look what M2 equals. So that's going to be here. So we've got minus a half for our L2. So M2 equals negative a half. Great, so now putting that into our equation, we have 2 times minus a half, which we know is going to be minus 1. Great, so that means therefore line L1 and L2 are perpendicular. Okay, so now part 3. Determine the coordinates of C. So what is C? So we're told line 2 has equation 2y plus x equals 25 and intersects at L1 at the point C. So we need to find the point in which L2 and L1 meet to get point C. So our line 2 equals, we rearranged it here, so minus x over 2 so we've got y equals minus x over 2 plus 25 over 2, and we've got L1, which we worked out to be y equals 2x plus 5. Okay, so to find the intersect point where these two touch, we need to make them equal to each other. So we need to have them, fortunately now we have them in terms that are equal to each other. So we both have them in y's. So I can chuck this into this y and set it equal to each other. So I now have minus x over 2 plus 25 over 2 equals 2x plus 5. Okay, and now I just rearrange and collect like terms. So first thing I'm going to do is multiply it by 2, the whole thing. So I'm going to have minus x plus 25 equals 4x plus 10. Okay, so I'm going to collect my x's on the right. So I'm going to add x. That will bring it to the right. And then I'm going to minus 10 to move that 10 to the other side. So I now have 25 minus 10 on the left hand side equals 4x plus x. Simplifying that, I have 15 equals 5x. So I now know 5x equals 15, x equals 15 over 5, which equals 3. Awesome job. Okay, so now we found our x term, we can use one of our L2 or L1 equations to find out the y term. So we have y equals 2x plus 5. So x equals 3, so we can have y equals 2 lots of 3 plus 5. So then y equals 6 plus 5, which is y equals 11. So my point C is 3, 11. Great. So now we're on to part C. Find the length of CD. Okay, so for this one we need to know our equation for length of line. So we know that length is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Awesome. Okay, so using C and D we need those coordinates. C is 311, D is 25, 0. Okay, and then I'll do the same thing with the xy, and so x is on the left, y is on the right, 1 and 2 to keep it consistent. Okay, so now I'm going to just plug it into my formula. So x2 is 25 minus 3 squared plus y2, 0 minus 11 all squared. Nice. That gives me square root of 22 squared plus negative 11 squared. Put that into a calculator, we get we get 11 root 5. And that's just part C. Okay, so then part D, we've been asked to calculate the angle ADB, give your answer in degrees correct to 1 decimal place. Okay. So let's get this done here. So I think the best thing to do with this one would be to draw it. So let's draw an axis. That looks fine. And let's get our points A, D, and B. So A is -1, 3. B is 2, 9. -1, 3, and 2, 9. And D was 25, 0. Okay, right, let's mark our points then. So we'll go up on the right in 5, so we've got 5, 10, 15, 20, 25. Go up in 3, 6, 9, so we'll go up in 3s. Okay, so marking point A, -1, 3, and that's going to be about here. We'll label that A, and I'll just put a little key next to them. Okay, point D, 25, 0 is about here. And point B, 2, 9. And that's about here. Okay, so now let's draw our lines where they connect. Have there, have something like this, something like this. It's not perfect. I have lock-on gridlock, so it's not going to be perfect. Okay, and so I'm asked to find ADB, so I know this is going to be the angle. So ADB, so this angle here, we'll call this theta. And there's a couple ways to do this. Because I don't have a right angled triangle here, I'm going to use cosine rule. I think that way it makes a bit more sense to me. So I know my cosine equation, which is cos A equals b squared plus c squared minus a squared all over 2bc. And now let's just write these onto our graph. So because I'm finding cos A, our side on the right needs to be A. So this needs to be A. So then this length is going to be little a. And we have, it doesn't matter which one we call B and C, so I'll just call this one B, this one C. I know that little a will equal the length of AB. I know little b will be the length of BD. And I know little c will equal DA, the length of DA. Okay, so using the equation from the last question, where it's x2 minus x1 squared plus y2 minus y1 squared. That's the length of a line. So let's look at AB. So -1, 3. B is 2, 9. It's going to give us a little a. So putting that into our formula, I'll just label this x, y, 1, 2. I'm going to have 2 minus -1 squared plus 9 minus 3 squared, which is the square root of 3 squared plus 6 squared. Put that into a calculator, that will be 3√5. Makes sense? Okay. So let's have a look at little b. And the coordinates we use are b and d, which are 2, 9, 25, 0. So putting those in, x, y, 1, 2. We've got 25 minus 2 squared plus 0 minus 9 squared, which equals 23 squared plus minus 9 squared, and that equals root 610. And now hopefully the last one, little c equals dA. D is 25, 0. A is minus 1, 3. Okay, so putting that into our equation, we have 20, so this is 2, this is 1, x, y. So x2 will be minus 1 minus 25 squared plus 3 minus 0 squared. That is minus 26 all squared plus 3 squared. Which is root 20 minus 26 all squared, so plus 3 squared, which equals 68, root 685. Okay, so now we've got A, B, and C. We can now use our cosine rule. So we know little a equals 3√5. We know b equals root 610. And c equals root 685. So just putting these numbers in, we're going to have, so root 610 squared. I'm going to run out of room here. If we put it in underneath, so root 610 squared plus root 685 squared minus 3√5 squared all over 2 lots of root 610 multiplied by root 685. And that will become, we can just put that into a calculator now, so he's messing about, so 610 plus 685 minus 3√5 squared, two times root 610 times by root 685, which this equals 0.966 9 to 4 figures, and that's cos A equals 0.9669. So finding out what A is, what this angle is, we take the cosine of -1 And that's going to be cosine minus 1, a equals cosine minus 1 of answer, which will just have 0.9669, which is 14.8 degrees to 1 decimal place. Hi guys, if you found this video useful, please consider liking and subscribing. All written notes will be available in the description. Best of luck with all your exams, and I'll see you in the next one.